All right, so ladies and gentlemen, hopefully you have your pre-lab. So this is due at the end of the class. So I'm going to, probably should just put it here at the table anyway. So what I want to do is we'll talk about the questions, and this should make doing the lab obviously a lot easier. So let's go to my table actually, because there is one problem, number 3, and I think I'm going to start with that one. We'll start with number 3. Okay, then I'll show you what I found for number 1 and 2, easy ways. Okay, so number 1 is asking you, okay, so how do you analyze an electrical circuit with multiple resistors? Some that are in parallel, some that are in series. What's the first step? Or what are the first steps to consider to evaluate? Hopefully you guys have a good idea of that, because I did finish grading everybody's homework that was due last night. And so you're getting a really good idea. So you can summarize that. And then how do you determine the current through the resistor? And then how do you determine the voltage through the resistor? So let's do number 4, where we'll have to do all the above. All right, let's see. It looks like I zoomed this a little bit too much. There we go. Okay, so number 4, in the circuit shown to the right, how much current is going through the 250 ohm resistor? So that would be, let me put my glasses on. That would be this, here's the 250. We want to know how much current is going through this guy right here. So that's the first question, I being the current. The next one is, what is the voltage drop across the 350 ohm resistor? So we want to know the voltage drop. Now, one way to symbolize the voltage drop would just be, see, I see here on the left side, I've got a battery with the longer one is the positive terminal, shorter one is the negative terminal. So on this side, it's going to be positive and negative here. So what is the voltage here? What's the voltage here? I'm going to call that V sub 3. All right, so then I look at it and I notice the voltage across this 350 ohm resistor. How does that compare to the voltage across the 200 ohm resistor? Steve Young. Is there a difference between the voltage across the 350 ohm resistor and the voltage of the 200 ohm resistor? Steve? You got to unmute yourself.
Oh, no, they're the same.
They're the same, exactly. Muy bien, muy bien. And by the way, the voltage across these two resistors are the same. And that's true over here too. The voltage across the 100 ohm and the voltage across the 250 ohm, they would be the same also. And interestingly enough, whatever the voltage is down here across these resistors, plus whatever the voltage here is going to be equal to what? Let's see, I'm going to ask Kimberly, what's the voltage of cross R1 and R2, I'll just call it V1, plus V3. What's that equal to? Can you tell from the circuit?
Wouldn't it be equal to the total voltage?
Exactly, which
voltage
is? Which is what? Which is the
24 volts.
Exactly, muy bien. Okay, so that's the first thing I realized. Okay, so in order for me to figure out what the amount of current is going through here, I need to figure out what the current is coming out of the battery. I'll call that I sub, let me see, this one's going to be called I sub 2, going through our resistor 2, and just plain old I. What's the battery, the current going through here? So the current into the battery and out of the battery, because I noticed that then the current gets split up. Some of it's going to go down this way, some is going to go down this way, then they collect together again, the I again, and they're going to split up again between this resistor here and this resistor here, then they collect, combine, and they become I again. So I need to know what is the total equivalent resistance, the whole thing. What does this battery see? It only sees one resistor. It only sees the equivalent resistance, okay? So I need to figure out what do I really have here. So let me see, I'm going down the list here. Fernando, what do you see here in the connection of this circuit? Who do you see parallel or series? What do you see?
I see 2 resistors in parallel.
Which ones?
R1, R2, and R3, R4.
Good, so he sees this 100 ohm in parallel to this 250 ohm, good, to 250 ohm. Okay, muy bien. And he also sees this 350 ohm in parallel to the 200 ohm. 200 ohm. That's true. So let's figure out what this would be then. Okay, I'm going to take another scratch paper here. A moment. Should have this ready. Okay, let's do it like this. There we go. Okay, so let's take care of the 100 ohm and the 250 ohm. Let's do that one first. The 100 ohm in parallel with the 250 ohm. So just those two, what does that become? What does 1 over R equivalent for those two become? How do you do that, Fernando?
Can you repeat the question? Sorry.
How do I simplify the 100 and 250 ohm? What's the equivalent of these two parallel resistors?
You would add 1 over 100 plus 1 over 250.
Okay, and that would give me the inverse of the total resistance. Good. 100 over 1 over 250. So let's figure out what these two are. And I'm looking for my calculator. Hijo de mi chica, ¿qué lo hice? Ah, caramba. All right. Well, if someone can figure, oh, aquí está. Aquí está, aquí está. All right. So I want to know what that is. Let's clear that. 100, take the inverse of that, plus 250, take the inverse of that. I get 7 over 500. That's very nice. What's the inverse of that? Yeah, it's 500 over 7. Okay, which is 71.4. Okay, so we're going to say that those two is like a 71.4 ohm. Okay, so this whole thing right here looks like a 71.4 ohmer. Okay, muy bien. And then we got the 350 and the 200. So let's figure out what that is. I got 350 ohms in parallel to 200 ohms. So let's figure out what that is. So 1 over R for just these two, got to be the same thing as Fernando did, 1 over 130, 350, and 1 over 200. Let's do what that is. 350, take the inverse, plus 200, take the inverse, and I have 0.007, blah, blah, blah. So what's the inverse of that? Okay, very nice, 1400 over 11, which is 100, and so that one is 127.272727. I think I'm going to say 0.3. 127.3 ohms. Okay, so these two together really look like 127.3 ohms. So Carlos, what can you tell me about those two? Let me redraw that for you. I have a 24 volts. One of them is 71.4 ohms, and the other one is 127.3 ohms. So Carlos, what can you tell me now about this circuit?
Since they're in series, the resistors would be added together.
Muy bien. So these two guys, I'm going to add them up. Okay, let's see if I can do it without my calculator. 127.3 and 71.4, 0.7891. Good job. So this is the same thing as a 24 volts connected to a resistor of 198.7 ohms. Muy bien. So now you can tell me how much current is coming out of the battery. How much current is coming out of the battery? The Iris, can you take that question? Here, how do I figure out the current?
You would divide the voltage by the equivalent resistance.
Muy bien. I don't have that memorized, but I do have V equal IR. So she already knew that I is the voltage over the equivalent resistance. Muy bien. So I'm going to put 24 volts all over 198.7 ohms. Okay. So that's here. Oh, I guess I'm going to have to clear that out here. Right? Yeah. Oh, yeah. You added that up. I'm going to say plus 71.4. Does that help? 198.7. Okay. I'm going to stick it to 198.7. So I got 24 volts divided by 198.7. So I know that the current going through here is 0.12078, etc. So now I'll take down to 3. 3 is good. And then at the very, very end, I'll take the final answer to 2.121 amps, 121 milliamps. Okay, so now I know that the current going through here is 0.121 amps. All right, so let me write that over here, 0.121 amps. So my question to you is, how much voltage is across the 71.4 ohms? So remember, the voltage across this guy is the same as this guy, and those two together look like 71.4. So I'm going to give that one to Luis. How much voltage is dropped across this first pair? How would I figure that out?
Isn't the voltage the same throughout the entire circuit?
No. All right, you guys, good. I'm glad I actually asked him to get this one wrong. No, I got 24 volts across this battery right here. Some of that's going to be used up by these two resistors. That voltage is the same as this voltage here, across this one, across this one. And that voltage V1 plus this V2 is equal to 24. So let me go back to this picture right here. I've got 0.121 amps going across the first 71.4. Remember, these are really 71.4. So the voltage has to be the current times the resistance. So the current is 0.121 amps times the resistance, 71.4 ohms. Okay, so let's take that. 0.121 times 71.4. What do I get? 8.6. I got 8.6 here. 8.6 right here. 8.6 volts. Okay. Now, Luis, now that you know that this is 8.6 volts across this resistor, same thing as across this resistor, how much resistance is across these resistances here?
So would it be the 24 volts minus the?
Yay. Muy bien. Two ways to do it. He goes, well, it would have to be what's left over. 24 minus 8.6. Let's do that. Let's say 24 minus 8.6. Okay, 15.4. I'm gonna make this big. 15.4 volts. Okay. Or let's say you wanted to just be super, consistent. It's when these two currents add up together, they're going to be 0.121. Let's come right here. 121 multiplied by this resistance, the 127. What is that? 127.3 times 0.121. What do you know? It's still 15.4 volts. Okay, so we did it both ways. It gives us 15.4 volts. Good job. Now, because I know that this is 8.6 volts, now you can tell me exactly how much current goes down through this 250 ohms. Let's see, we'll give that to Josue. Josue, how much current is going to go through this 250 ohm resistor?
So the current, it would
Again, always go back to what you know. V is equal to IR. I want current, so I must be V over R. Now, how do I figure out the current going through this resistor?
you would so we're looking for the current, which is I, and we would do V over R, so we would divide the volts over the resistance.
Okay, good. So what's the voltage?
The voltage is 8.6
Muy bien, 8.6 volts, and resistance?
over the resistance, which would be 71.4.
No. Now we're going just through this one. Okay? This was 250 ohms. See, some of the current, some of this 0.21 went here, some went that way, down this way, and some goes this way, this way. But we're only interested now in this current, which is 250 ohms.
That would be 250.
Good. All right, so let's figure out what that is. 8.6 divided by 250, 0.03. So through here, I got 0.03, I'll put 4 amps. Now, Josue, if 0.034 went this way, how many are going this way? Remember,
Well,
this is 0.121, so it's right here, 0.121 amps. Some of it got split off to 0.034. So how much is this way?
you would have to subtract that.
Exacto. Well, that's one way to do it. Let's do that. 0.121 minus 0.034. Okay, so this tells me that I've got, going through this current, going through this resistor, 0.087 amps. Okay, because when they add up together, they'll be 121 again. So right here, it's back to 0.121. But let's say you wanted to say, well, prove it to me. How come you did it differently for the first one? Let me see, someone's asking me a question. Oh, okay. So somebody has a frozen screen, so that means I need to reshare, because that happens. That's because we're competing with everybody on the internet. So I'm reloading my screen again. Okay, hopefully you guys can see that. So we had 0.121 amps coming here. Some of it gets down here, this resistor, and the remaining goes down in this resistor. Then they come together, they add up, it's 0.121. So here we did the V over R, and we got 0.034. Well, what if we did it over here on this side? Because remember, the voltage is the same. Well, let's see what it is over here. I'm running out of room here, huh? Pull this down here. I'm going to say I is equal to V over R. It's still 8.6 volts divided by 100 ohms. 100 ohms. I don't need a calculator for that. Shoot, that would be 0.0086 amps. And here we got 0.087. You guys see that? Now remember, I'm getting this because I rounded off. I probably shouldn't have rounded off to 3 significant figures. It should have gone to 4. But you see that this is 0.008 close to 0.087. Get that right here? 8.6. Did I do this right? Write this right here. 0.087. Okay, are we okay now? This is 100 ohms, yeah. Okay, so we got 0.087 and 0.031. Very good. Now, the next question here was, what is the voltage drop across the 350? And we already figured that out. We already figured out it was 15.4. I want to make sure you guys understand how to do this problem, because all the other problems are the same, just a variation on a theme. So let me back up and summarize what we did for this problem. We were given a battery. We're giving these two resistors in parallel, and then these two resistors in parallel. And they only were interested in what's the current through this one that I highlighted, and what's the voltage across the other one that I highlighted. So we had to figure out first what impedance, that's the other word for resistance, impedance, the total equivalent resistance that the battery sees. So we broke it down. I think it was Fernando recognized that these were in parallel, so we figured out what that was. Then these were in parallel, figured out what that was. Then Carlos correctly realized, oh, there's a series. Okay, so we added those up. And so we ended up with a total equivalent resistance of 198.7. We divided that into 24 volts to figure out how much current went through there. So I had 0.121 going through. But it's a good idea to come back to this one first, because once I figured out that I have current 121 amps to this equivalent resistance of 71.4, I was able to determine what the voltage was, which is 8.6. So 8.6 is across this resistor, and 8.6 is across this resistor, the one I highlighted. Okay. We're able to figure out 15.4 volts across these two from here also, because 24 is all we got. And so Kimberly correctly determined that the resistance across the bottom two, the voltage across the bottom two resistors was just 24 minus 8.6. So then I put that up here, 15.4. And that's the voltage across this 350 ohm resistor. Now you can also determine the current the same way. The V over R, I could take 15.4 volts and divide it by 350 ohms. And that tells me what the current is going through that resistor. And I can subtract that point from point 121 to figure out the current through here, or do the same thing. The V, 15.4, divided by the R, 200 ohms. Any questions? I recommend you guys give yourself more space, like do a whole page. Would have been better, because really I look at how much space I took up. So it's not all crammed in there. Everything's easier when you have lots of room. Okay, any questions? All right, so here we go. Question number 1. Explain how to analyze an electrical circuit with multiple resistors, some that are in parallel to another and some that are in series. What's the first step? Okay, so let me see. Juan Diego, what's the first step?
Isn't it to determine which ones are in parallel and which ones are in series?
Okay, all right, good, yes. Analyze which one's in parallel, which one's series. Okay, good. And then what's the next step?
And then combine the ones that are in parallel and the ones that are, and then the ones that are in series, separate.
Okay, and then what?
You combine them.
Right, and then after we combine them, then what? So in other words, when you say combine them, you're going to determine the equivalent resistance. Sometimes you see R equivalent. Okay. So yes, I agree with them. So first analyze it, determine which one's in parallel, which one's in series, then keep analyzing until you finally get one total last equivalent resistance. Okay. After you got the equivalent resistance, which is hooked up to your battery, now you can determine how much is the total current being supplied by the battery. Okay. So once you figured out how much current is being supplied by the battery, then you can go back to the previous, what do you call this, drawing, schematic, circuit to determine some other information like the voltage across groups. And then the voltage across the other one. Is that good? Okay, muy bien. That was a good answer, good answer. So Cristobal, number 2 and 3 are kind of easy, so why don't you take those? In the circuit above, what's required to determine the current through a resistor? What do you need, Cristobal?
You would need the voltage and the equivalent resistance.
Exactly. Well, or that resistor. Not be careful what you say. When you said equivalent resistance, that would mean this one, right? So really, you need the voltage across a resistor and its resistance, the actual resistance. That make sense?
Yes.
Muy bien, muy bien. Okay, Cristobal, what about number 3? What is required to determine the voltage across the resistor?
You would then need the current and the resistance.
Exactly. Muy bien. Excellent. Good job. I got to tell you guys, the reason why you guys are doing so well on this is because you're prepared, did your homework. Makes a big difference. Makes a big difference. Like, oh, I'm actually seeing that. Oh, someone's asked me number 2. Number 2, the question is, what is required to determine the current through the resistor? So tell us again, Cristobal.
To determine the current, you need the voltage and the resistance of the resistor.
Exactly, of that particular resistance. Muy bien. Okay, good job. Okay, moving on down to number 5. Bummer that there's a con assignment, I think it's due on Sunday, that makes you really understand this, but at least you'll understand it before you have the lab, before you do the lab, hopefully. So how do you measure current with the ammeter and how do you measure voltage with the voltmeter? Okay, and then how do you measure resistance with the, well, I put multimeter, could be an ohmmeter also. Okay, so I'm going to show you guys what I found for you guys, some good pictures that I had ready for you guys. Let me get that. Okay, let me grab it here somewhere. This one's current. Okay, and now I got to say stop share. Basic. Let me go back here. Okay, hopefully you guys can see this. All right, so what I did was I want to show you guys a picture. How do you measure current with an ammeter? And the answer is You have to put the ammeter in series. It has to be in series. That means you have to open up the circuit and stick in your red lead on one side and your black lead on the other side. Why? Because if you put it in parallel, an ammeter has really, 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 really low resistance. And if you put anything in parallel with a really, really, really low resistance, then your equivalent resistance is going to be even smaller. That's a bad thing because that'll make the current go through the ammeter. You don't want to fry your ammeter. Fry meaning put too much current, burn it, and then you'll have an electrical fire or whatever. So it has to be in series. Okay. So let's see which one's a good answer. I was looking for a good example they had here. Let me close that up. Good example. I guess the best example I found is being covered up by our pictures here. There we go. In this corner right here, hopefully you guys can see in this corner right here, here's my battery. Here's a resistance. Okay, this is another symbol for an LED, say a light bulb. Here's my ammeter. Ammeter, measuring amps, and that's your unit for current. Notice how it's in series. Okay, so the answer is you must connect it in series because you will screw it up if you connect it in parallel. Any questions on that? Okay, again, why would it mess it up if you put it in parallel? Well, when you got things in parallel, now you got to do the one over, and any resistors in parallel, the equivalent resistance is always smaller than the smallest resistance. Okay, and these ammeters don't have much resistance because it doesn't want to add a load to the circuit. All right, let me switch over to the next tab. Did it switch over? Yes, it did. Okay, how do you measure voltage? Now, you guys saw me do this in the classroom, and I like this picture right here. So let me see, I'm gonna pick someone randomly. Andrea, what do you think? How are you supposed to measure it? Oh, the answers are right here even. How do you hook up your voltmeter to measure voltage?
The voltmeter has to be connected in parallel.
Correct, in parallel, which makes sense. Because remember, anything that's in parallel, the voltage across those two things, let's say if two resistors in parallel, they're gonna have the same voltage across them, huh? So when I did this in the classroom, all I did was I put one lead on one side and one lead on the other side, and that tells me the voltage across whatever I'm trying to measure, okay? Now you see this guy here is measuring the battery. This is what I was telling you guys, you should all know how to do when you have children. My toy doesn't work. Well, let me see if the batteries are down. The battery doesn't work. Battery lost its power or its charge. Okay, so it's in parallel. Now, those of you in the classroom got to measure a resistor. So that's the next question. I think I have one right here. Measure a resistor. You guys got to do this in class yourself. And there's the answer right there. So let's see. Let's see, Dayanara, you were in class. So how do you measure a resistor with your ammeter? Are you with me, Dayanara? No. Okay, Steve, you were there in class. What do you say, Steve?
In series?
Oh, look at it.
Oh,
When you touch on each side of it, you are actually in parallel. See how one lead, oops, someone's sending me a message. Okay, so you have one lead on one side, my red one, and my black one on the other side. So they're in parallel, okay? In series would mean that I had one here and one the other one next to it. Okay, like in that circuit that I showed you for the current. All right, so let me go back to that one. Make sure you guys get that. I gotta move these, our little pictures. This one over here, this one right there. There's an example of your ammeter, could be your multimeter switched in the position of current, in series in the circuit, okay, as opposed to in parallel. All right, any questions? And yes, you can use your chat box because that's working. Okay, so I'd like to switch over to the other handout that I gave you guys. Let me go to my desk or my table here. It's not a dining room table until the semester is over. Okay, oops. I'm gonna stop share and I gotta do a new share. There we go. All right, so this is just more review, which like anything else, the P word, this is going to start looking easier and getting easier and easier for you guys. All right. So I just thought this was good practice. It's 2 pages. So I really want to hopefully get to the second page. Okay. So let's see. I'm going down the list here. Let's see. Yasmin. Yasmin, here we go. What they're asking for is, here's my circuit. I have these two, and well, I have this circuit. You tell me. And then we want to get to what is the equivalent resistor. So Yasmin, what do you see here in this one?
The 4 and the 4 are in parallel.
All right, she sees 4 and 4 in parallel. So what do we know when they're the exact same value? When the 4 and a 4 in parallel, what's that? What's the equivalent to those two? If you don't know, it's
half of it.
I'm sorry, what is it?
It's half of it.
It's half, that's right. How does she know that? Well, let's see, 1 over 4 plus 1 over 4 is 2 over 4. I invert that. 4 over 2 is going to be 2. Yeah. So what's half of 4?
2.
2. Good. So this guy right here. So now notice all we did. We redrew this circuit over here. I got the 3 ohms. And here, this is now my parallel combination of the 4 ohms. And I got this 5er. Okay, Yasmin, what else do you see?
So now the 3 and the 2 are in series.
Okay, good. And what's the equivalent to that?
Be 5 ohms.
That's right. She knows that they're 5 ohms. This will be 5 ohms. Okay, good. They're 5 ohms because all we have to do is add them. So now, Yasmin, what do you see?
Now it's in parallel.
To the other 5 ohms. So what's the equivalent resistance now?
So it should be 2.5.
Exactly. Good job. So this would be 2.5 ohms. 2.5 ohms. Now there was no battery. It was just wanting you to analyze that. Okay, muy bien. Muy bien, muy bien. All right. Let's see. Going down my list here. Sergio. Sergio, you're up. I won't make you do the whole thing now. Taking a look at this circuit, what do you see? Are you there, Sergio?
Yeah.
All right. Do you see anybody in series, anybody in parallel? What do you see, Sergio?
I see the 2 6s in parallel and
Oh, the 2 6s in parallel. Okay, good. We're gonna stop you right there. Good job. He says, I see the 2 6s in parallel. Good job, good job. So what is the parallel combination then gonna be for these two? What is a 6 ohm and a 6 ohm in parallel? What does that become? Brianna, can you help him? Brianna, you with us?
Would you add it?
Not when they're in parallel. You only add them when they're in series. Add them when they're in series. In parallel, we got to do the 1 over. So look back here, the 4 and the 4. She knew that when they're exactly the same, it's going to be half. Because 1 over 4 plus 1 over 4 is 2 over 4. Then flip it, 4 over 2, it's half. So if these are both 6 ohms, what's it going to be? Brianna.
1 over 6 plus 1 over 6.
Yeah, okay. 1 over 6 plus 1 over 6 is what? What's 1 over 6 plus 1 over 6, Brianna?
2 6.
Okay, what's the reciprocal of that?
6 over 2.
Which is?
3.
Yeah, 3. So what do you know? Half of 6. So I got a 5 ohmer and now I have a 6 ohmer. Okay, good. Let's go back to Sergio. What else did you see? Because I cut you off. What else did you see, Sergio?
I also see that the 6 and the 2 is in parallel with the 5 and the
Okay, but before you say that they're in parallel with these, but how are they connected to each other?
in series.
Exactly. And what do I do when they're in series?
Add them.
Good job. Which is what then? 6 and 2.
8.
All right, good job. All right, so I got 8 ohms here. All right. Okay, good. All right, so now that is what you're already trying to say, but they're in parallel. Well, yeah, but wait a minute. What about the 5 and the 6? Oh, 3, sorry, 3. This is 3. What about the 5 and the 3?
They're also in series.
Exactly. What does that become then?
8.
Exactly. So I have 8 and I have 8. By the way, I'm skipping it. It's also connected to a battery here in parallel. Okay, now, Sergio, since you're doing, oh, you know, I'm going to stop you guys because somebody's, again, froze. So I'm going to have it reset again. Okay, so Sergio, so we have an 8 because of the 6 plus 2, and then we have the other 8. So now what happens?
It'll just be equal to 4.
Exactly. So this would be the battery connected to 4 ohms. Exactly. And I really like our equivalent, not just our equivalent. Okay, muy bien. All right, so let's see here. Let's move on down. Does anybody have any questions? Because I really want to get to the back side of the page. I'm only going to start this one for you guys so we can get to the back side because that'll really help you guys for the lab. Let's see. And Mr. Ralph did not come today, right? So no Ralph Tranchi today, unless I messed up there. Okay, let's see. I'm gonna start from the top. Fernando, starting with this one right here. Let's start with 2A, just this one right here. What do you see?
There's 2 resistors in parallel and 1 resistor in series.
Okay, let's talk about the one in series. Which ones do you see are in series?
Oh, 1 ohm and 1 ohm.
Oh, okay, all right, now I'm good with you. So he sees the 1 ohm and 1 ohm, so I'm gonna have to redraw it on a different piece of paper here. Let's go right here. He sees those, and what happens when they're in series?
You add them up together.
Okay, good, so what will it be?
2 ohms.
Exactly, and now notice how I'm putting them together, 2 ohms, all right. Okay, that's what you meant by the 2 resistors in parallel, huh?
Yes.
Okay, these are all connected in the same line. Okay, so now what do you see?
Now resistors in parallel.
Okay, so what does this become?
That just be like the answer.
Yes.
Just be 1 ohm.
Exactly. 1 ohm. Muy bien. Okay, good job. So that one is just 1 ohm. The equivalent resistance there is 1 ohm. All right, let's see. Carlos, let's take this one. No, B here. What do you see?
I see that there's some that are in series,
Okay, which ones do you see in series?
the far right ones.
Exactly. Always start with the far right. Good job. And what does it become?
2 ohms.
Okay, so you know what? Instead of drawing another piece of paper, I'm going to say ignore those yellow and we're going to say 2 ohms here. Okay, good. So now what do you see? Should be a straight line, but now what do you see? You got to ignore these yellow. Those are gone now. So now what do you see?
Now they're in parallel.
Good. Now he sees these 2 in parallel. And what are those now going to be?
Those are going to be 1.
Exactly. So all this is 1 ohm. Right on. Now, does that look similar to this circuit here? You guys see that? There's the 2 ohm. There's the 1 ohm up there. And all this here became 1 ohm. You guys see that? So what is the equivalent resistance going to be? Carlos.
1 ohm.
Yes, sir, Bob. All right. I'm going to let you guys do this one and you'll find that it's just the same thing. Okay, now let's go to the next page. All right, because this is where it gets, where you now have to break it down to how much current is going through here, how much current's going through here, and how much voltage is across each of these things. All right, so let's start with the top one. The top one, I have a 12-volt battery. And notice the 12-volt battery is in parallel with the 6 ohm resistor. That means that the 6 ohm resistor has 12 volts across it. There's a 6 ohms and it has 12 volts across it. Okay, I don't know how much, I know that, oh, here we go. All right, so if there's 12 here, whatever the voltage across the 2 ohmer plus the voltage across the 4 ohmer, that voltage plus that voltage better equal 12 ohms. Okay, so now the question is, how do I figure out the current? Okay, this battery only sees one equivalent resistance, just sees one. So I'm going to go down here. Iris, so how do I figure out the equivalent resistance for this guy? What do you see first? Let's break it down. What do you see first?
Oh, I see 2 and 4 in series.
Muy bien. 2 and 4 in series. What happens when they're in series then?
You just add them up.
What would it be then?
6.
6. Okay, so I got 6 ohms here, 6 ohms here, and I have a 12-volt battery. All right. What do you know? So now what's the equivalent resistance of the 6 ohmer in parallel with the 6 ohmer?
3.
3. Is that what you said?
Yes.
Okay, good. 3 ohms. Muy bien. And I have 12 volts. Okay, I'm not drawing that very well, but okay, there we go. So my question to you is, how much current is being supplied by the battery? How much current is coming out of here and into here? Iris? Always start with V equals IR.
Yeah, sorry that. So you just multiply, or you just divide.
Exacto.
Oh.
Okay, good. So what do I put in the numerator here?
2, 12, I mean, sorry.
12 volts, good. And the
Little
resistance
baby.
is the equivalent resistance.
3.
Good. So what's the current?
4.
All right, 4. So I got 4 amps coming out of here. It's going to get split up. Some of it goes this way and some of it goes that way. Okay, so I got 4 amps, some of it this way, some this way. Now I know the voltage across here already. I know it's 12 volts. So how much current is going through here? I'll call it I little 6. How much current is going through here? Iris, just like you said before, it's voltage over the resistance. And what's the voltage across this resistor?
12.
12, good. And it's 6 ohms.
So it'll be 2.
Exactly. So I know that this is 2 amps. So if 4 amps are coming in here, 2 amps goes that way. How much is left over?
4 amps.
4 amps is feeding it. 2 amps goes out that way. How much is left over?
Wait, what? Can you repeat that? Sorry.
4 is going to this point right here, okay? You figured out correctly that 2 is going that way. So how much is going this way? 4 goes into this spot. Node, we call it a node. That's 4 is going in there. 2 goes that way. How much is left over?
Oh, I'm sorry. It's just that it keeps moving slow.
Oh, sorry. Okay. So 4 amps is coming from the battery. 2 amps goes to the 6 ohm resistor. So how much is left over to go to the other branch, to the 2 and the 4?
Oh, 2.
2 amps, right. So it's got to be 2 amps. So notice I got 2 amps. So 2 amps goes through this guy and 2 amps goes through this guy. All right, well, if I know how much current goes through here and V is equal to IR, then the voltage here, let's see who's next. Jeremy, I know you're having trouble, but Jeremy, maybe you can send me a chat. How much voltage is across this 4 ohm resistor if 2 amps is going through it? Okay, remember V is equal to IR. And I've got, yes, you're correct. He says 8. That's right, 8 volts. Okay, I took the current. So now if 8 volts are on this side, how much is on this side? Remember, I've got total of 12. Jeremy, you want to tell us that? If 8 was used up, was dropped across this resistor, how much is across this 2 ohm resistor? Remember, I got 12 total. Well, you can do it the same way if you don't see it. I know that I got 2 amps going in, and V is IR. 2 amps times 2 ohms is also going to be 2 times 2, which is 4 volts. 4 volts. And sure enough, 4 volts plus 8 volts is 12 volts. All right? And that's where they come up with these numbers. Now, what's power? Remember, power is the current times the voltage, and that's in watts. So once you know the current and once you know the voltage, then you figure out the power by multiplying them. Okay? So I really want to get you guys to get through this one, at least do. These are really simple circuits. Let's go to this one right here. I got 6 volts battery connected to a 1 ohm resistor in series with the 2 ohm resistor. Let's see, Luis, what do I do first, Luis?
To find the current?
Yeah, I did figure out anything, the voltage across here and the power, everything. What's the first thing I need to do?
You need to identify that they are in series.
Good job. Okay, these are in series. Good. So what do I do when they're in series?
You add them and you should get 3 ohms.
All right, so I'm going to put them right here, just because I don't have much space on this paper. 3 ohms, and then we're going to get rid of this lamp. Okay, so really it looks like a 3 ohms. Okay, so how much current is coming out of the battery then?
It would be voltage over resistance, and that's 6 over 3, so 2.
All right, I got 2 amps. 2 amps. All right, so that 2 amps, that's still there. We can get rid of this now. 2 amps is going through here, and then 2 amps going through here, all the way around, huh?
Yes.
Okay, so how much voltage is across this first one? How much voltage is across this one? Remember, V is equal to IR. Well, what's the voltage across this one if 2 amps is coming in?
2.
Yes, he did 2 times 1. So I got 2 volts here. What about here? What's the voltage across here? Remember, I got 2 amps going in here.
So 4.
Yeah, so I got 4 volts, which makes sense because I got 2 volts plus 4 volts got to equal to 6 volts. All right, so let's see. What do we have here? On the 1 ohm resistor, the current was 2 amps. And it was also 2 amps on the other one. And you're right, you figured out the voltage for the first one was 2 volts. And the second one was 4 volts. Okay, and my power is the current times the voltage. So what am I going to do, Luis? How many watts does the first 1 ohm resistor have?
So it's 2 amps times 2 volts, so it's 4 watts.
Muy bien. And what about the second one?
It would be 8 watts.
Muy bien. All right. Okay, good. Going down my list here. Let's see. Josue, let's look at this one. What do we have here? This time I'll be dry.
They're resistors in parallel.
Okay. So what happens when they're in parallel?
You would do, well, 1 over.
All right. 1 over 6, 1 over 3. Okay, I'm not going to use my calculator for that. That's the same thing as 1 over 6 plus 2 over 6, which is 3 over 6. So what's my equivalent resistance then? Josue.
It would be, you said 3 over 6, it would be 2.
Right, 6 over 3, which is 2 ohms. Okay, so really it looks like I got a 2 ohmer connected to my 6 volt battery. Really should be 6 volts right here, plus minus. Okay, so how much current is coming out of the battery? Josue.
Current, it would be, well, voltage equals current times resistance.
Right, V is equal to IR. Okay, so what's I equal to?
I equals VR.
Okay, V over R. Okay, and so what's that?
It'd be 6 over 2.
Good.
Which equals 3.
Good. So I got 3 amps then. 3 amps coming out of here and going into here. 3 amps. So some of that 3 amps is going to go through the 3 ohmer and some of it's going to go through the 6 ohmer. Now, Josue, what's the voltage across these 2 resistors?
The voltage?
Yeah, what's the voltage across the 3 ohmer?
So we have the resistance and the voltage.
Notice that they're in parallel to the battery.
Mm-hmm.
So anything measured here and here is going to be the same thing as a battery. Measured here and here, still a battery. Okay, so because they're in parallel, we know that the voltage here is 6 volts across this resistor. And it's also 6 volts across this resistor because they're in parallel. Does that work, Josue?
Yeah.
So now tell me how much current is going through the 3 ohm resistor.
The current. So we have the volts. So then to find the current, then we would have to do V over R.
Okay, good. I is V over R. So what's the V here?
6.
Right, 6 volts. And what's the R here?
3.
3 ohms. So what's the current?
2.
2 amps. Okay, so if I got 2 amps going through here, how much is left over to go to the other one?
1.
1. How did he know that? He did 3 minus 2. Or you could have done V over R, 6 over 6. So I have 1 amp going through here. 1 amp. Okay, so there's 6 ohm, I have 1 amp. 3 ohm, you figure 2 amps. The voltage has to be the same when they're parallel. 6 volts, 6 volts. So now tell me the power. What's the power?
For the first one, it would be 6.
What's the units?
It would be power. It would be watt.
Correct. So it'd be 6 watts. And what's the next one?
2 times 6, which is 12 watts.
Good. 12 watts. Muy bien. All right. Very good. Now, the last one. In this case here, we had resistors in series and then in parallel. That was the example one. The first one, though, was really easy. I shouldn't have done that. I should have redrawn it. Sorry about that. So I got just 2 resistors in series in the battery. Here, 2 resistors in parallel in the battery. Here, now we've got both combined. So I have, what do I have here? Who's next here? Let's see. Cristobal, tell me what's going on in this circuit. How can I reduce the circuit, simplify the circuit?
So the 2 ohms and the 2 ohms are in parallel. So you would do that first.
Okay, what is it?
That would be 1.
Yes, I'm going to redraw it here. 1 ohm, and then this one here, 1 ohm, and then I've got 6 volts. Okay, so now what happens?
Then since they're in series, you would add them both, which would equal to 2 ohms.
Muy bien.
Which would be the
2 ohms.
equivalent resistance.
All right, good. Okay, and I got 6 volts. Okay, muy bien. So tell me how much current is being supplied by the battery? How much current is coming out of here or going into it?
It would be 3 amps.
Oh, okay. Tell me how you figured that out. V over R. Good job. He's way ahead of us, you guys. 6 volts. 6
Over the
volts
resistance would be 2.
over 2 ohms. Good. 3 amps. Good job. So 3 amps. Okay, so by the way, 3 amps is going out. It's coming in. If 3 amps is coming in, well, that's how much current went through this guy, huh? You guys see that? Because it's going through here, well, that's how much, well, after these add up together, it's still, so you know that the current here is 3 amps. So Cristobal, if 3 amps went through this 1 ohm resistor, I'm gonna write that down, 3 amps. What's the voltage here across this resistor? What's the voltage here? 3 amps goes through this 1 ohm resistor. What's the voltage?
It would be 2, right?
Wait. V equals IR. I've got 3 amps is my R, my I, and my resistor is 1. Resistance is 1.
Oh, it would be 3.
Yes. So I is 3 amps and R is 1 ohm. It'd be 3 volts. Okay, so if I got 3 volts across this guy and the whole circuit is being supplied by 6 volts, how much is left over here? Because remember, these two are going to have the same voltage across them because they're in parallel. So if I got 3 volts across here, how much voltage is here across this?
It'd be 3.
It'd be 3 volts. Muy bien. Because 3 plus 3 is 6. Okay, so the 3 volts across both the 2 ohm resistors are 3 volts. Muy bien. And you figured out 3 volts on this 1 ohm resistor. Okay, now we got to figure out what the current is. If you know the voltage here is 3 volts, how much current is going through here? I'll call it I2. How much current is going through there?
It would be 3/2, so it'd be
All right.
1.5.
I have to do this. I still do it this way. I still have to write it down. All right, he's like, oh, it's 3/2. Okay, 3 volts over 2 ohms. So 1.5, huh? So I got 1.5 ohms. Okay, 1.5 amps. So over here's got to be the same, huh? Right? 1.5 amps. And what do you know? The 1.5 amps comes through here, and they add up together and they become 3 amps. Yeah? You're right. 1.5 amps, 1.5 amps. Okay, muy bien. You guys are awesome. So what's the power then? Oh, start with the one on the bottom here. Cristobal, what's the power dissipated?
It would be 9, right?
Yes, power
9
is
watts.
current time. That's right. Current times 9 watts. All right. What about these? I have to use calculator for that. 3 plus 1.5 maybe. 3 times 1. Oh, caramba. 3 times 1.5. I think it's 3 plus 1.5. 4.5, huh? 4.5 watts. 4.5 watts. And now you guys have solved the entire circuit. Is that good? You guys are awesome. So Monday, we will go through the practice test. And remember, priority goes to all your questions, okay? So